Okay, so we're going to graph a tangent curve, and it's got an A and it has a B. So the period's going to change. But before we do this one, let me just review a regular tangent curve. So y equals tan of x. And then what we do is we kind of straddle it about the y-axis. And so remember, on a normal tan curve, just, a regular one, without any transformations, it has a period of pi. And so you're going to put half of it over here and half of it over here. Kind of eyeball that. So pi over 2 and negative pi over 2. Now that's where your asymptotes are going to go. So you want to graph, for one period, at least you want to graph the two asymptotes, and then you're going to have three other points. One is going to be at the origin. One is going to be at pi over 4, and it'll be up there at 1. The other one will be at negative pi over 4, and it'll be down at negative 1. And so you get a curve that looks something like that. And if you need to do another period, then you just, mark off another pi and do the same thing. Okay, that's just a regular tangent curve. So now we're going to kind of mimic that with this one. Okay, so let me get some kind of coordinate system. A lot of times I just draw these by hand. I mean, you can get a ruler and draw straighter lines. You can use graph paper. I'll leave that up to you. Okay. I don't usually put graph paper on the test. I do usually provide lines, though, so you'll have a little direction. Okay. And the reason for that is because the period's always changing. Okay. So first let's look at the not amplitude. There's no amplitude. We're going to look at the stretch factor. So it's 0.5 for the stretch factor. So there's no reflection about the x-axis. It's not negative. And so we know instead of going up to 1 like we normally would and down to negative 1, we're only going to be going to 0.5 and negative 0.5, okay, for those points. This graph does not have a vertical shift or a horizontal shift, so we're just working with a stretch factor and a change in the period. Okay, so now for the period, it's going to be pi, because a normal period for tangent is pi, over the absolute value of b. So in our case, it's going to be pi over the absolute value of pi over 2, which invert and multiply, do the absolute value, and you're going to get 2. So I'm going to mark off 1, 2, and I'll mark off negative 1, negative 2. Now, remember, this is the whole period, 2. So you've got to put half of it on the left and half of it on the right. So my asymptotes are going to go at negative 1 and 1. Okay? Then I can put in the points that I know. I know it's going to go through the origin. Oops. And then I know it's going to go, it would be at a half, and negative 1/2, because I got to go halfway in between those. And it's going to go up to 0.5. So there and down to negative 0.5. So it's a little more compressed. I said stretch factor, really it's a compression, isn't it? Okay, so it looks something like that. That's what we do for graphing a tangent curve. Now if you wanted to go another period, you could think about that. Here we were at 1, I'll write that in, and so a period is 2, right? So I'd have to go to 3, so I'd have to go out here to 3, and I would have another asymptote, because that would end the period, right? And then I would have a point here, and then I would go like halfway in between these. So whatever that is, like 1.5 and 2.5, I guess. They could ask for the ordered pairs. I don't know that they normally would, but you should be able to see them on your graph pretty close. And so it's going to look like this. And it should look similar to the first one I drew. And you can keep doing that. You'd go out, you know, if you wanted to do another period, you'd go 4, 4, 5, you know, and you draw another asymptote and you do it again. Okay? And you can go in the other direction as well. Normally they might just ask for 1 period or 2 periods. This one said sketch a graph of 1 period, so we really just needed this part here. We didn't need the other part. But I was just saying, you know, if you wanted to do more, those graphs keep going. They're periodic. Okay?